In exercise 18, we're given two functions. We're told that they're graphed on the same set of axes, and we want to know which statement is true about the solution to the system. Remember, when we have a solution to a system of equations, it means that it satisfies all of the equations. In case you don't remember, the word satisfies means it makes them true. Read each of the choices carefully, and you'll find your answer without doing too much work. The first choice says that 3, 0 is a solution to the system because it satisfies one of the equations. But to be a solution to a system, it has to satisfy all of the equations, and so choice 1 is not the correct answer. Choice 2 says the point 9, 0 is the solution to the system because it satisfies one of the equations. That's great, but to be the solution to the system, it has to satisfy both, so choice 2 is out. Choice 3 makes sense. 6, 3 is the solution because it satisfies both of the equations. That makes sense to me. That's what it means to be a solution to a system of equations. So 6, 3 is a candidate to be a choice, to be an answer for this problem. Let's take a look at choice 4. 3, 0, 9, 0, and 6, 3 are the solutions because they satisfy at least one of the equations. Nope. To be a solution to a system, you have to satisfy both of the equations. And so choice 3 is our answer. If you weren't certain, you could certainly take your graphing calculator and graph both of the equations. When we do that, we see that the point of intersection is the point 6, 3. 6, 3 is the solution to the system because it satisfies both equations. In exercise 19, Miriam and Jessica are growing bacteria in a laboratory. Miriam uses the growth function f of t equals n to the 2t. Jessica uses the function g of t equals n to the 4t. We have two equations, one for each of the girls. N represents the number of bacteria that they started with. We're told that Miriam started with 16 bacteria, so her function is f of x equals 16 to the 2x. Notice that I changed the t's to x's. This is because I'm going to use my graphing calculator in order to find my answer. If I look at a table of values for Miriam's function, I can see the number of bacteria that she had after the number of hours have passed. Let's take a look at Jessica's function. In terms of x, we have g of x equals n to the 4x. We're told Jessica could start with 32, 16, 8, or 4 bacteria. We'll write a function for each of those with the proper n value substituted in. 32 to the 4x, 16 to the 4x, 8 to the 4x, and 4 to the 4x. Use your graphing calculator to create a table of values for each, which matches Miriam's table. Look carefully, and we see the one that matches Miriam's table is choice 4. Jessica should start with 4 bacteria, and so choice 4 is our answer. In exercise 20, we're given a recursive sequence. Remember, recursive sequence is a sequence that uses a previous term to find the next one. We're told that the initial term, f of 0, is 2. We're told that the rule for the function, to find the next term, we take negative 2 times the current term plus 3. So the next term is negative 2 times the current term plus 3. We want to find f of 2. Set up our lines so that we can fill in the blanks and create the sequence. The beginning term was 2. To get the next term, we take negative 2 times that term and add 3. Negative 2 times 2 plus 3 is negative 1. That's the next term. To find the final term, we do the same process. We take that term, negative times negative 2, and add 3, and we get 5. So the term f of 2 is 5, choice 3. In exercise 21, an astronaut drops a rock off the edge of a cliff on the moon. The distance is given by the function d of t equals 0.8 t squared. What is the average speed in meters per second between 5 and 10 seconds? In this case, we're looking to find the average rate of change. When you find average rate of change, you use the slope formula, y2 minus y1 over x2 minus x1. We need 2 points in order to use the formula. There are a couple of ways we could get these points. Option 1 is to use substitution and use the function to find the values. d of 5 gives me an output of 20. So at 5 seconds, the output was 20, and so the point is 520. 10 seconds, we calculate d of 10, and we find the output is 80. So the point is 1080. We now have our 2 points, 520 and 1080. If evaluating these functions by hand isn't your cup of tea, feel free to take the function, put it into your graphing calculator, and go to the table. Look at the table. You'll find at x is 5, you have an output of 20, so the point is 520. When x is 10, the output is 80, so you have the point 1080. Again, 520 and 1080 are your points. Label the points x1, y1, x2, y2, and substitute into the slope formula. Reduce the fraction, and you find that the average rate of change is 12. The answer is choice 1. In exercise 22, we're asked to factor the expression p to the fourth minus 81 completely, and we're given 4 choices. If you look carefully, you'll recognize p to the fourth minus 81 is a difference of 2 perfect squares. And when we have a difference of 2 perfect squares, we can factor them into a conjugate pair. A squared minus b squared is factored into a plus b times a minus b. We recognize the a value is p squared, and the b value is 9. And so we can factor that into p squared plus 9 and p squared minus 9. Be careful, you might be tempted to choose choice 1, but not yet, because p squared minus 9 is another difference of 2 perfect squares. We can factor the difference further. A is p, b is 3. So we can factor p squared minus 9 into p plus 3 and p minus 3. Be careful, p squared plus 9, while they're both perfect squares, is not a difference, which is subtraction, of perfect squares. It's a sum, and we can't factor that term any further. Look carefully at the choices, and choice 3 is our answer. In exercise 23, we're told that the Postal Service charges 46 cents to mail a letter weighing up to 1 ounce, and that each additional ounce costs 20 cents more. Let's take a moment to understand this problem a little more clearly, because you might be tempted to choose one of the choices that's clearly incorrect. Let's create a table. 1 ounce costs 46 cents, and each additional ounce is 20 cents more, and so it increases at a rate of 20 cents per ounce. You might be tempted to choose C of z equals 0.20z plus 0.46, but that would suggest that the y-intercept was 46 cents, and it's not. The y-intercept is when x equals 0, not when x equals 1, and so while you might be tempted to choose choice 2, it's not correct. Take a look at the table for that choice 2. It doesn't match the table that we've made, and clearly it's incorrect. So let's understand this problem a little bit further. Suppose we take each of those 4 choices. This is probably the easiest way to go about that problem. Put each of the equations into your graphing calculator, using the variable x, of course, and see which of those tables matches the one that we created. Choice 4 has the same values as our table, and so choice 4 is the correct equation. How could we determine this algebraically? Well, since we know what the value is when x equals 1, we could use the point-slope form of a line, y minus y1 equals m times x minus x1. We could use the point 1 and 0.46 and substitute them into that equation for y1 and x1. When we do that, this is what we get, and if we add the 0.46 to both sides, we end up with an equation that very clearly looks like choice 4. Choice 4 is our answer. Another option would be to perform a linear regression. Take the values we created in our table and put them in a list and spreadsheet in your calculator. Pull up the data and statistics screen with a scatter plot and perform the linear regression. Y equals 0.2x plus 0.26. Look at the choices carefully and notice that none of them match this equation. Choice 1 and 2 are already in slope-intercept form. They clearly don't match. How about choices 3 and 4? If we take choice 3 and distribute the 0.46 and then combine like terms, we have c of z equals 0.46z minus 0.26. That doesn't match. If we take choice 4 and distribute the 0.20 into the z minus 1, we end up with c of z equals 0.20z plus 0.26. Ah, that one matches our equation. Choice 4 must be the answer. In exercise 24, we're told that a polynomial function contains the factors x, x minus 2, and x plus 5. Which graph could represent the graph of this function? Remember that we use factors to identify zeros. So if we take each of the factors and set them equal to 0, we can find the zeros. X equals 0, x equals 2, and x equals negative 5. Look at the graphs carefully and identify which functions have these zeros. Graph 1 has a 0 at negative 5, at 0, and at 2, so that's a good candidate. Graph 2 has a 0 at negative 5 and 2, but it does not have a 0 at x equals 0, so that's not a choice that we'll consider. Graph number 3 has a 0 at negative 2, 0, and positive 5. That doesn't have the correct zeros. And so it looks like the only graph that matches this description is graph 1. Look at the choices carefully. Choice 1 is our answer.